And I think that's one of the main reasons why this was such a nasty bug, or not such a nasty vulnerability, is that Log4j is not the main product. It's something supported in the product, and a lot of people didn't even know that they were using it. So that was kind of that made it worse. Though, for me, the 4 components that made it a really severe incident or severe vulnerability were that it had a large attack surface, because there were many Log4j deployments. It was a remote code execution with the rights of the Java app, which is of course not something you want. But the main part for me was that it was easy to trigger. You can trigger it with user data in an unauthenticated session. So if an access point would log your system name, for instance, you can just change your system name with the vulnerable string, or the string that that triggered the vulnerability, and that would trigger the remote code execution. So who was involved in mitigating Log4j? Only 2 people? Well, 2.5. Yeah, so it's yeah, I think a lot of IT people were involved. It was just before Christmas, of course. So yeah, there were a lot of memes going around at that time. I love these ones, and you can look them up, and there's a lot of things going on. All right. So when this happened, I wanted to see the packets, right? I mean, we're all talking packets, so I wanted to see the full attack. But the problem was that Chris Greer did a nice session on Log4j, and he used a capture file for malware traffic from Brad Duncan. But those were only the probes. Those were only an injection of a string, but they didn't show the full attack. So how to get the packets for a full attack? Well, I don't want to start a video. It's my session. Come on. Get out of here. So I first had a stupid idea. Like, why don't I just run a vulnerable application, put it on the internet, get myself hacked, and capture the packets, right? Perfect. What could go wrong? Well, the thing is, when you're attacked, usually your system itself will attack other people, or will do DDoS attacks or whatever. So whenever you're attacked, you kind of attack other people, which I don't want to do. And also, I didn't want to put my public IP address in traces that I'm going to use for a session, because I like my public IP address to be private, which is kind of a strange way to say. So that was a stupid idea, and I dropped that. So next idea was, okay, let's do it in a controlled environment. Let's create an environment where I can do the attack in a controlled way. So I would need a vulnerable system, and then I would need an attack system that can actually run the attack. So I discovered the video by Hack5, in which they used the proof of concept by Cosmer, and that's actually a vulnerable Java app, and also the LDAP and the ACP server that you need to deploy the exploit. Oh, don't hijack my session. So what happens? Yeah, I shouldn't include videos. That's learning. It's the first time I do it like this, and shouldn't do it. So the first thing is, how does an attack like this work? And for me, at first, it wasn't clear what was really happening. So I followed some sessions online from other vendors and other instances. So I was looking at, okay, what do I need to make this happen? Well, first you have an attacker. It sends some data to the application server with some user data containing the Jindy string. This is all based on that you can include the Jindy string, which triggers a name resolution in the logging engine, and that retrieves some Java code that will eventually do a remote code execution. So some data contains a string. The application server is logging it to a logging server. Could be the same system, could be a different system, and that system will do the Jindy lookup. In this case, to an LDAP server. There's other mechanisms that can be used as well, like RMI or DNS. So the LDAP server returns a response containing a HTTP reference. Then the logging server will get that HTTP reference, or follows the HTTP reference, gets the response containing the exploit, and at that time the exploit is being executed because it's a piece of Java code that's being retrieved, and it will be executed by the Log4j instance. So that's basically how this whole thing works. In my lab, I created one system as an attacker with the IP address 203.0.113.217. I'm not sure whether people recognize these subnets, but these are the testnet subnets. So these are not publicly, they look like public addresses, but they're actually not, they're used for testing. The same goes for this subnet, it's also one of the test nets. So, and with that, I created the packets that made this attack. If you, yeah, we can look at, I think we're going to switch to Wireshark, but this is, if you follow that link, it will be in the presentation. If you follow that link, you can download this trace for yourself. But let's look at it in Wireshark instead of in a, oh, it's my calendar. You're not supposed to see my calendar. Let's see, where is my attack? And I should have cleared some things already. One thing you see that's already been done is I added attacker and victim names to the systems. You can do that by right-clicking, edit resolve name. So if this wasn't resolved yet, I can add a name like, let's change it with lowercase. So now it's attacker. And that's funny, it changes to victim as well. So edit resolve name, victim, which makes it a little easier to understand what was going on. As you can see, the full through the handshakes, acknowledgements, etc. So it's clogging up my system or my display. So I filter a lot for TCP length greater than 0, which just removes your through handshake, it removes your bare X, just shows you the application data, which makes it easier to follow. So if you look at the login post and I look down, there's a cookie. Let's see, no, there's actually, in this case, there's nothing in there that is vulnerable, so that's okay. So the second post, I try to do a Jindy LDAP search. So you see in the post data, you see that I added a string that will trigger the remote code execution. You don't see any LDAP session here. That's because I'm using the wrong port. So in the last one, I'm using the correct port. I'm adding an LDAP session to port 1389. And then you can see that the victim server, the logging server, is now actively opening a connection to an LDAP server. You don't see this as LDAP, so I need to do a decode as. Anytime that you see an application that's not on a default port and Wireshark doesn't recognize this, then you can change. So I'm going to change port 1389. I'm going to change the section to LDAP, which means now I can see what's actually being exchanged. So this A object is being retrieved, and the result, if you can look close here, is a reference to HTTP 203.0.113.217.8000. So it's going to retrieve an object from the attacker system. And you can see that it's doing that because the victim is actively getting the exploit from the attacker system. So in this next phase, it downloads the exploit. It's a Java class, so it's a Java program that's going to be executed. And if you look into the ASCII data of that, I'm not sure whether you can see it. Let's see. No, I can't. Should make a connection to port 9000 something, but that's not. Yeah, that's not easily listed. But the Java class is actually an executable that will connect to a reverse remote shell. As you can see in this next session, you see that there's a connection from the. Let's follow this stream. I have a follow stream option here, filter button. Who knows about dynamic filter buttons? like the filter buttons and the dynamic things. Yeah, some people do. Okay. Filter buttons are one-click filters. So if you have a filter like http.request, if I apply that, I don't need to apply, but if I apply it and I click on the plus, it gives me the option to label it. So this is a request filter. I click on OK, and now there's a filter button that as soon as you can now, with one click, you can apply different filters. This is really useful, makes your life a lot easier. And one of the filters that I use a lot is the one that's actually dynamic. And this part means take the TCP stream number of the currently selected packet, fill it in, replace this with that number, and then do apply that filter. So this means if I'm on a connection with stream number 1, if I click on this, it will get all the packets that have stream number 1. So if I look at HTTP, I've got here 0, I click on TCP, all sessions from stream 0 are collected. So again, HTTP, now I pick this one, session 3. Again, I click on this one, and the whole session of HTTP session 3 is displayed. So very useful filter because you can navigate through trace file quite quickly this way. But I was distracting because I was going to look at the full session of the reverse shell. So let's go back to my previous filter of everything. Oh, well, let's just type it in. TCP.length greater than 0. So we had the full attack phase, and the last part was that actually a reverse shell connection was opened by the victim to the attacker, and in that reverse shell, if I do a follow TCP stream, I always like to use the command line of the keyboard shortcuts. So it's Shift Option Command T in this case. You can see that I did an ls. It showed me the files. Who am I? I was root because the application was running as root. So I'm actually now root on the victim system just by using this LOG4SHELL attack. That easy. It's really just some piece of information that gets logged to the vulnerable log4j library, and boom, you're exploited with whatever executable that the attacker wants. So this was fun. Now we have the package. Now we know how it works. But how does it work in the real life? Because this is a lab. So I want to go one step further. So things we learned. Well, I didn't create a copy of my base profile. I should have had, but I just changed the profile that I was using on filtering on greater than 0. It's very handy. Decode as is very handy. Right click, edit resolve names, and show packet bytes, which I didn't. I did it follow TCP stream, but show packet bytes is really interesting as well. So phase 2, I wanted to now I wanted to get attacked, but I didn't want to get attacked fully. I wanted to see how often I would get attacked if I was vulnerable. So I created a honeypot based on the library from MalwareTech. They had a log4j tools repository, and it had a simple honeypot that tested whether any string in an HTTP request contained the dollar curly brace open, because that was a sign of maybe an attack. So I created that honeypot, I activated it, I opened my firewall so traffic could come in on that honeypot, and I started listening and see what happens. Then there was another script in there, fetch payloads, that did the actual step of fetching the executable that was presented by the attacker. So my workflow first was, okay, I look at the honeypot logging once in a while, and when I see an attack, I manually download the exploit, and I will go about analyzing it or doing something with it. The problem was that a lot of times, when there's an attack, the attack system would be available only for a couple of minutes or a couple of hours. So if I get an attack in the morning and then in the evening I started looking at it, I didn't get anything. So I added a WhatsApp alert. So it would be alerted through WhatsApp. That's my main platform of messaging. So that's the one I monitor. So I created a bot that would give me output whenever there was attack. And then I would run to the laptop to see if I could download the exploit. Funny part is I enabled the honeypot yesterday again, and I got, let's see, I got 2 attacks yesterday and 1 just when I was in the elevator. So maybe someone comes in during the session, but it is still being exploited. But there's a difference between being probed, like somebody tests if you're vulnerable, or being actually exploited. In this case, you see that there's a Jindy name lookup using DNS. This is actually my public IP address, which I wanted to hide, but it's in there. But I changed the config of my my cable modem changed, so I have a different IP address now, so it doesn't matter anymore. But fun part is, otherwise I would have needed to anonymize this, but this is my old IP address. So I had fun creating the server name and the response string that I sent to anything that came into my server. And this is actually what this does. It opens the DNS connection, but this doesn't download an executable. It's just a lookup, and I don't think you can be infected by this reference. But this is the way to test, because it's very easy to set up a DNS server to log everything that comes in. So a lot of researchers, but also probably attackers, they just probed everywhere and to see whether there's a DNS request coming in, because then they know that's a vulnerable system. So this is a probe. Another one came in that was really crazy. Like, you see all these Jindy strings in all the headers, but they forgot one thing. Can somebody spot what's wrong with this one? Why is this not going to work? If you look at the start of the string, it should start with a $sign. Only when it's $sign and then something between braces, then it works. The $sign is missing. So this is someone trying to scan but not doing it the right way. Good for you. There was a lot of people hitting on the bandwagon, as was I, to probe or to analyze or to see what's happening. You saw tweet names that had the Jindy string in them. You see that Jindy string appear in so many places. So next, this is actually these are 3 requests coming from the same system. One with the Jindy string in the get header already in the URL. One in the cookie, and then the next request, it was using the user agent to test whether that was logged, and ended up in a vulnerable log4j instance. And then the last one, it was using the basic authentication string, which is kind of silly, because who is logging their full basic authentication credentials? I think that's a privacy issue if you do that. So probably, but somebody wanted to see whether that was vulnerable. And that's the fun part of if you run a honeypot like that, you attract all kinds of traffic. Yeah. So let's see how that looks in Wireshark. Let's clear this session. It asked me to save because I changed the name resolution, and name resolution blocks are actually saved in your PCAP file. So whenever you use manual name resolution or manual resolve names, it will change your file and it will ask you if you want to save it. Okay, let's see. Yeah. Yeah, I think this was the file I wanted to show. So again, I'm the victim. Now there's public IP addresses coming in to that victim. Actually, I think I want to show something else. It's a very large file. Takes some time. Because not everything that comes in is, of course, a Jindy attack or a log4j attack. There's multiple things. So let's filter on the HTTP requests. It's nice. We had a button for it. Just created it. Let's see what happens. So there's these are my own, you see, attackers. So these are my own sessions. This is also a system of myself, Proton. But then you see all kinds of stuff coming in from all kinds of addresses from the internet. But you see also other vulnerabilities, like some system probably has an API with a product config that shows you things that it shouldn't show. There's, let's see, this is just updating things. There was one I wanted to show because there was actually an attack. Let's see. I think it was somewhere in the beginning. Here you go. Remember who was at SharkFest Virtual last year doing the CTF? A couple of people. I had a friend of mine had a router, and it didn't work very well anymore. It was really old, and I asked, "Oh, can I have it?" Because he had some problems with DSCP with it. So I wanted to make traces of that router to see whether I could get interesting traces to show. But I didn't have the login credentials, and I didn't want to factory default it yet because I wanted to have the configuration, and I didn't want him ask him for the password because I know he would have. Well, I don't know. So I thought, can I get in without his passwords? And so I started looking and I found a vulnerability for that specific version of that specific router OS, and I was able to log in. And actually, this attack is the one that I used on that router. So it was funny to see that it was actually exploited in the wild, that people tried to exploit that. You see here a SOAP action with some scripting and retrieving stuff, and so this is an attack. Also, I could have followed this one as well, but we're going to look for Jindy attacks. So let's say asp.request contains, and I'm not running 3.7, unfortunately. Otherwise, I could have used the new raw functionality. Is that already in 3.6? No, right? No. So I need to escape the, oh, sorry. I need to escape the curly brace. And I think I need to escape it twice. And it's still not working. Why? That's funny. I did this before. Why asp.request? No, maybe I should do it like this. This is how I did it before. Not sure why it doesn't work on. Oh, it's not. I should put it on http.request.url. It needs to be a string field, and http.request is not a string field. It's just a Boolean field. Okay, so let's look for or scan for Jindy strings. There's quite a few of them. Of course, the first ones are my own traffic. And then there's all kinds of requests. Let's say in here, you can see that this works because the $sign brace open, again, $sign brace open, and now it will look for an environment variable called NAN. If it's there, it will do something, and otherwise it will just output a J. And so this is actually only a J, and so it tries to hide from the intrusion detection system this way. If you didn't configure your intrusion detection system correctly, then you wouldn't notice this. But if you put in the right IOCs, then this will be noticed as well, of course. Those are all kinds of ways that people try to find vulnerable systems and evading all kinds of security systems. Let's see. Actually, the responses are not the one that I need. There's another one. There's another one. So it happened quite a bit. Here's a simple one. Whatever. So what would you expect after you receive the string? And if you're vulnerable, you would see an LDAP connection to this IP address and port, and then you would get an HTTP connection to somewhere else to retrieve the class. So that, but since this is just a honeypot, it just receives this this traffic like this. I can create a coloring rule for this. Let's see, coloring rules. And what I usually have is opvallend means stand out in Dutch. I usually have one very colorful filter and http.request because I don't want to see those response anymore. If I want to have something stuck out, I do it like this. So if I now go back to my request, I should have trimmed this file a little bit down, I think, but gives me some room to breathe. I use this method a lot of times if I'm interested to see how often something happens, I'll just create a very colorful color and I'll just scroll and you can see quite easily how often something gets by. So it's not that often, but you can see that there's quite a few attempts to attack my system or attack all kinds of systems because I'm just one of the systems being scanned. All right. Oh. So yeah, create a filter button. I didn't do that, but I created a filter button for requests and create a coloring rule. It really helps you in your troubleshooting. Now what? Now I have the attacks. I can see what the exploits are. Now I want to download them and I want to execute them. But you need to be very careful, of course, because I don't want to infect myself in a way that I'm really infected. So I wasn't sure about VM outbreaks, whether that was possible or not. So I created I took an old PC, installed Ubuntu and VirtualBox on it, had a dedicated VLAN going straight through my firewall to the internet. It wasn't allowed to go anywhere else. And I closed it down that it couldn't do anything except when I manually added some IP addresses that could connect to, because I didn't want to infect other people or DDoS other people. And that's why I blocked everything and I added the export server manually. And then when I saw the CNC traffic, I added that manually. And that way I was sure that it wouldn't hurt me or any other person. And let's see what happens when you do that. So let's open up. Okay, it's one. So this is the traffic that I'm interested in. As you can see, they're marked already with that things are being exploited. I think this one, yeah, this one is red. How do you call it? Magenta 2. So in this, if I follow this TCP stream, you see an HTTP request with the GIND strings in a couple of headers. And what it actually retrieves is well, it actually retrieves just my Honeypot output, of course. But if you look at the GIND string, so I can press Command or Shift Command O for open packet, show packet bytes. You can see that it actually will do an LDAP request for this object. And if you look at those base 64 information, this is actually kind of a bit different attack. Instead of rerouting it to a web server, this one automatically creates a class. So if I want to decode that, I'm going to, let's see, 120. So I'm just extracting the base 64 part of it. So I'm adjusting my boundaries. So this is just a base 64 part of the string. I can decode it with base 64 within the show packet bytes screen. And you can see that it will execute a wget. It will get an exploit. It will make it executable, and it will run it. That's basically what it will do on the system. So what this LDAP request will do, because it embedded what it needed to do, it will send it to an application server. That application server takes these commands, turn it into a Java class that will execute these commands, and will return the Java class back to you. But we weren't running this I'm still on the Honeypot side, so this was not done. So I manually started to download the exploit and see what's in the exploits. So I think I go to HTTP request. I download the exploit myself. So if I follow that stream, you get what's in the exploit, and in the exploit itself, you see that it goes into one of the directories listed here. This OR means that okay, if this succeeds, don't do anything else until the semicolon. So it tries to find a temporary directory to download an exploit, an x86 exploit, and it used wget and curl. So it tried both versions to see whether if one is not available, the other one would have been. When it downloaded it, it saves it in the file exploits. It makes it executable, and it will run it with the parameter log4j2. It does the same for MIPS platform, MPSL platform, ARM platform, ARM5, ARM6, ARM7, PPC. So it tries. It doesn't know on what kind of system it lands. It just tries to do all architectures to see which one works. That's basically what this exploit will do. So what I did, I downloaded the exploit on my vulnerable system. So I'm going to the trace of my vulnerable system. And that's actually a 2 gig file. So what I'm going to do, I'm going to apply a read filter, because I know that the attacks that it started from this, which created the 2 gig file, are actually UDP traffic. So I'm just reading this file without the UDP traffic. Whenever you have a large file, you don't want to first pre-process it, but you want to have it quickly or more quickly in your filtering, you can just exclude things with the read filter. So hopefully that makes it a little more quick. Meanwhile, I can show you how you can do something like that. So another thing that's nice is T-Shark minus, so this is case 01 vulnerable system. And what I can do is I don't want to output any packets, but I want to get statistics of all the conversations at the IP layer to see which IPs were actually generating the most traffic. So now it's a contest between Wireshark and T-Shark. Wireshark wins. Damn it. As everybody knows, I'm a fan of T-Shark, or most people know. What I sometimes, when you do it like this, you can, one thing I should add is I have a profile called minimum. So if I add minimum as of minimal, I think, what's my profile name? Minimal, yeah. This way I disable reassembly, I disable all kinds of protocols that I'm not interested in. It's basically only layer 4 information, and that makes it a lot quicker. Let's see if that's really true, but it should be quicker. Still, it's 2 gigs, so. And as you can hear, my laptop is blowing because of the Zoom. Well, it's actually T-Shark now, but it's also Zoom that's taking quite a bit of CPU. Well, let's let this run for a while. Let's look at the trace in Wireshark. By the way, when you see me reshuffling my columns, or resizing my columns, it's actually Shift Command R, Shift Control R on the Windows. It will reshuffle or resize all the columns so that everything is visible. I should have brought my cheat sheets. I have cheat sheets at home, but I didn't bring them. Shame on me. Yeah, so what you can see here is that I at first manually, well, I don't think manually, I think I executed the exploit. So let's do HTTP request again. You can see that it's now pretty quick in filtering because there's only 1400 packets left of those 2 gigs of file that I loaded in. So the first run is slow, but after that, I'm able to quickly navigate through the file. So here you see all the wget commands. If I look at the agents wget, this one is the curl one, and all these exploits are being collected. And after that, let's see what happens after that. So let's clear this. Do again a tcp.length greater than 0. Oh, and not. Well, let's just do not tcp.port equals 80. Let's see what else is happening. So you can see that there's a that my vulnerable system is actually going to saturnbot.net.net. So it's even in DNS it is known that this is a botnet. So it tries to make a command and control connection on port 59666. I'm wondering why they did the 666. I don't know. So I can follow that stream, and it doesn't actually show me much. It's a very short stream, but if I look at the conversations, statistics conversations, and I look at the TCP sessions, and let's just filter on not TCP port equals 80. I like that Ronald mentioned that you in the future you can filter within the conversations. Now I always filter in the packet list and then go to conversations and then limit it to the display filter. So I get only the things that are matching the filter. So there's a couple of sessions that are short, but this one is long living. This is a long session. As you can see, I'm not sure if you know, but these two columns together form like a timeline from the first packet to the last packet. And in gray, it's shown when the first packet was shown and until when the last packet was shown. So you get a little time overview of what's happening in your trace. So this is actually a very long-lived session. So I'm going to filter for that, apply filter, selected A to B. And let's do now a follow stream on this. It's binary, so it's not something that you really can understand what is happening, but in here you see something with ports or whatever and MTU sizes. It's actually a command for a DDoS attack. So in these, I couldn't find it yesterday when I was finalizing this presentation, but I found a document back then that described a little bit on the binary format of this Mirai network command and control protocol. So if we would have the full file, that command would show an attack. So let's see what happens if we open up. Let's do just one attack and not all of them. So let's just filter out. Like this one is not too big, so I want to keep this one. Let's say T-Shark minus minimal MR case 01 vulnerable system, and then say minus y not IP dot error in, and I'm going to exclude the ones that are really having a lot of traffic. Let's see this one too, and this one, and this one. I think that's it. The rest is small, and I'm going to write it to x.pcapng. So now I'm creating a file with just the attack to this system, which is only 152 megabytes. So it's easier to open. Of course, it takes a while again. And let's see if we. I think that IP address should be visible in the. So this is 38. That means it's 2654 D. Oh, actually E4. So let's see if we can find that. So find, and then frame contains, what did I say? 226.4 54 0E and then 4. So now looking for the hexadecimal representation of the IP address, and it already found it in this frame. Something on port 80, and that IP address is, let's say, should be in here somewhere. In this part, or is it in the? No, can't find it now. But let's open the file because it's already done. This was an extra that I didn't prepare for, so it's always nice that you think of things that are not working. So this is getting the exploit again. All the versions of it. Let's just scroll down. And here you can see the attack traffic already, but let's go just before the attack traffic. There should be a command. Let's do filter on tcp.port equals 59666, and then go back. No. And go back again. Go back. No. Why is it not? Oh. I'm gonna look for the command that triggered this attack. Yes, actually this one. So this is from the botnet command and control server towards my system. There's a command initiating the attack on this IP address. I did do back then I did do a breakdown of these strings, but I didn't make any notes, so I don't know anymore. But there's a couple of attack types. So there's a UDP, TCP. I can't remember the other ones, but it had parameters for MTU size. It had parameters for the amount of seconds that you need to do the attack. If you look at the first and the last part of this this attack, it's a pretty rounded amount of seconds. Let's filter for this. IP.address equals 38.84.14.4. I think it was either 30 seconds or 10 seconds or something like that. So capture file properties. Here are the properties for the whole file, and this is the properties for the filter traffic. And as you can see, it was almost exactly 20 seconds. So in that command to do the attack to this particular system, it said do an attack for 20 seconds. If you look at the bandwidth, in this case 60 megabytes of megabits per second. I was expecting 100 because I was on a 100 megabit interface, but probably somehow it was slower than that. But, and the fun part was that I had like my own laptop where I was working, and I had another monitor attached to that to the vulnerable system, and I was just monitoring what was happening, and I could see the DDoS attacks running by quite often, which was kind of fun to see. So T-Shark is your friend. A minimal profile is really handy if you want to quickly analyze or quickly select things, disable the most protocols, disable reassembly, disable TCP analysis, sequence number analysis, stuff like that, and you have a very quick profile that that will work. Let's see, how are we? No attack coming in. Sorry. But then what? And the last part is actually where I had the most fun, and it was the least expected also. I was monitoring that while I was working. I was monitoring a little bit of what's going on, and I noticed in one night that there was actually a dual attack. It was because all of the attacks that I analyzed were Mirai, were all what we just saw. It had a Mirai command and control connection, and it was just using it as a botnet to provide DDoS attacks to other systems. By the way, the traffic that you saw was filtered by my firewall, so it didn't enter the internet. It was just local to my system, or to up till the firewall, of course, because I didn't want to really attack someone. But I saw in one time I saw an attack that it had a Mirai bot, but it also had another one. It had actually two bots in it, and one of them connected to a Mirai command control channel, and one connected to IRC. So I followed that, and as I was working and kind of with a half eye monitoring what was happening, I could see that there were some commands that didn't look like some automated stuff. It looked like somebody actually typing in commands to do something. So that got my interest, and I started looking at that, and then I thought, hey, this is IRC. This is someone logged into IRC. Maybe I can talk to this guy. So let's see what happened there. So let's see. Yeah, it's actually. Let's take this one. It doesn't have the attacks in it. So let's see what we have here. Of course, there's the management of the system. Actually, I think this is the point. No, this is actually where I downloaded the attack already. Which, if you look at it, let's say. So it downloads something called initd, and it's actually a script doing all kinds of stuff. All kinds of stuff. I don't know. And then after that, you could see that it tries to connect to something. Actually, this is my just Ubuntu trying to connect to the Ubuntu servers, but everything was blocked, also traffic to Ubuntu. So it's also to Ubuntu. Here it's trying to download some of the attacks. So these are things that were in that other script. They were now downloading things and executing them. And let's see. Oh, this goes on for a little while. Let's not scroll. Let's just drag. So it was downloading quite a few objects. So let's do tcp.port equals 80 and then not. Okay, so tries to do DNS. I think I blocked DNS as well. Here you can see that it tries to connect to, this time it's a different port, 27159. And it doesn't work. It doesn't work because my firewall is closed, so I needed to open up that port so I could connect to it. So let's see when, and tcp.length greater than 0. So here you see a connection. If I do a follow stream on that, you can see probably the same thing as you saw earlier, just some binary data, some ports that were used for an attack. So this is again the Mirai command and control session. Let's go back to this one. No, apply. So this is the Mirai command and control section. It's actually opening up because of I think a fault in the script. It opens up multiple connections to multiple command and control centers. But it will open up also on port 1081. If I do a follow stream on that. Let's do a follow stream on it. It actually says connecting too fast. So there is an IRC login, but it's not accepting it. So let's look at the conversations to see whether there's a long-lived version of that. TCP dot port equals 8081. And then go to the conversations. because it took a while before it had a good connection. And I think, where is it? Well, I can sort, of course, on the amount of bytes. Oh, limit to display filter, thank you. That helps. So this one is a little longer. So let's follow that one for a second. Applies filter selected A and B. And now do a. So this is the IRC session that was following or watching on my screen. And here you can see a private message doing something nproc uname in A. That happened quite a few times. Okay, so this was not the session that I was looking for. So let's create a filter, a column for the. Oh, first we need to interpret this as IRC, of course, because it doesn't. So decode as port 80. Let's say this is IRC traffic. Oh, IRC. Okay. So now it knows how to interpret it, and now let's look at the private message, because that's what I find interesting. So I'm going to filter for the private message. So I'm going to drag the filter up here, so I have all the private messages. Let's see, why am I not seeing what I want to see? Is there also requests? Yeah. Something is not going well. Let's see. Okay. TCP port 80 equals 8081. Let's actually, and HTTP contains. Let's take a shortcut because I know the username was Rooks or whatever, how you pronounce it. And that's actually not in my system. Other file maybe, yeah. Oh yeah, this was the one before. No, I don't know. Let's see what happens to the other file. I'm mistaken. Yeah, this was, yeah, you're right. I split it up. This was the attack with the DDoSes, and then there was the next day there was this IRC traffic. So I'm indeed in the wrong file. Of course, this should be not HTTP but frame. So if I now filter again on the private messages, I do end selected, and now what I want to do is create a column for the commands that were executed. So I'm gonna add this. Let's put it, I don't know, just after here. So now you can see the commands that were given. Now these are the automated ones, and then I saw ID, lstemp, trying to execute something, trying to execute it with different parameters. And that was in a way that it was really showing that it was manual and not automated. So the next step was, okay, let's log into IRC and see what happens then. So open up the manual IRC. I had to kill my my bot because it only allowed one connection per IP address, and since I only have one IP address at home, it needed to be I needed to log out from that one and then log in from the other one. And let's see. It should also. This is the response, and I should also filter on or actually any requests. Okay. Actually, it's not showing the. Oh, this is actually request trailer. Okay, so I just need to edit my column to include also the request trailer. You can add 2 different fields in one column. Not sure if you guys know that, but if you do an OR here, you can just show the output of 2 separate fields in one column. So my message to this attacker: having fun on my system, and it took like 10 minutes almost to get a response back. I said hello from Netherlands, hello from Brazil, and I said something like, yeah, I said this command that you're giving won't work. I asked him, what are you doing on my, what are you using a botnet for? He said sports. I don't know what he means. I assume it's a him, but it doesn't really matter. He said sports, so I don't know what he means. Probably to just experiment. He didn't answer that, and then I said I was following with Log4j infection, and well, he understood it, and well, I wanted to go to bed. It was already 1 o'clock or 1:30 in the morning, so I was in the night, so I was going to bed. So I warned him, be careful though. Yeah, right, thanks. Bye. So that was really funny to engage in a conversation with somebody that's attacking your system. Later on, I thought I need to connect back and really warn him, because this is, I excluded his IP address, by the way, because I don't want this guy to get in trouble because I'm presenting on this. Yeah, I wanted to go back to warn him, like, you shouldn't do this, because yeah, he attacked my system. So he was basically, even though my system was, I could handle it, but this is not good, right? So yeah, and he was executing DDoS commands to the botnet. So he was actually also attacking other people with the botnet. So yeah, I expect this to be someone young, finding out how this stuff works, not really having any harm in mind, but doing harm anyway. But I never connected back. No, because it was late. I wanted to go to bed. No, you can do all kinds of funny stuff. I pondered whether I should call us ISP or whatever, but then I thought this is probably somebody that doesn't have any real harm in mind. So yeah, I just let it go. I warned him though, be careful. So I hope he took that to heart. So let's get back to the keynotes. So drag and drop columns, one of the tips for this. And this is the actual IRC conversation. I made a picture of it. Yeah, it was really funny. So takeaways. It's great fun analyzing a CVE. Like if there's something really bad going on, there's a way to analyze it, and it's great fun to do. Please do take precautions and do it safe. I mean, you don't want to accidentally hurt yourself, but most of all, you don't want to hurt anybody else in your process of analyzing stuff. Make packet captures, like we don't. Who's running permanent captures in their home network? See, 4 people. Yeah. So, do you have approval from your family? Do they know? Okay. Yeah. Yeah. Well, when I installed my permanent capture solution, I had a girlfriend, and she did understand, and she didn't want me to capture her traffic. Like, what? This is my house. I want to capture my traffic, but she didn't want that. And yeah, of course, I had to change my plans. So yeah. So make use of Wireshark profiles to isolate your settings. I didn't do it now. I changed my base settings, so I need to move that back. But what I usually do is, when I start to work on a case for a customer or this, I make a copy of my base profile, give it a name specifically for that, what I'm doing, and then work from that. And then I can just delete it after I'm done without clogging up my base profile. Display filter buttons are a real lifesaver. I use them all the time. Packet coloring, to the main ways I use packet coloring is either to make something stick out, with a very bright color, or I use a white background with a light gray text to make something disappear, but not really disappear. So I don't want to attract my attention anymore, but it will still be visible. Well, one marketing slide. This is what I do. Well, it's in the presentation. So any questions? Well, the question from the audience here is, do I know if he took down his CNC server? No, I didn't check. No. And if it wasn't available anymore, it doesn't mean he took it down. It could be he moved it to another AWS instance or whatever. So yeah, I didn't go any further than this. No. Yep, let's go back to Wireshark. You mean this button, right? Yeah, it's actually not a follow TCP stream button. It's a button to select the packets from this particular stream. And once I do that, I can use the shift command option T to actually do a follow TCP stream. So it was actually a two-step process. But this button is really handy if you have a TCP stream here. It will filter on all the packets that belong to that stream. And the way it's doing that is it takes the value of the currently selected packet, fills that in or replaces this word by that value, and then executes the filter TCP stream equals that value. Yep. If you do have any more questions, feel free to email me, of course. I'm always happy to answer questions. So, yeah. All right. Thanks a lot and enjoy SharkFest.